Hello out there and welcome to my channel. Today I will talk about my Myford ML 7 lathe, the repairs and upgrades I have done to it. According to the serial number, it was built in 1961. I got it about 1984 with the cabinet stand. I was told that the lathe had spent its early life on a ship for minor repairs. I think that the lathe is a good, reliable, robust lathe that I have been very fond of over the years, although it has some minor issues. Because the headstock spindle has solid bearings, you can only run it about 800 to 900 RPMs, but you can live with that. Another thing is if the flat bedways are worn, especially the area that guides the saddle. This lathe had this issue with worn bedways, but I found a way to fix the problem that I will show you in a minute. The saddle was from the factory meant to be guided by the inside of the front bedway and the outside of the front bedway. I never understood why the saddle could not be guided by this side. My saddle was worn at this area, and so was the bedway. Not so much. You can adjust the play, but then the saddle could only be moved a certain distance, close to the chuck where most of the machining are done. Further down the way and the saddle would bend. So I decided to try to have the saddle guided by this area of the bedway instead of this. And at the same time, you have a much wider area using this side instead of this short side. I measured the vertical sides of the saddle and found that they were totally parallel, machined from the factory, and so was the bedways vertical sides machined totally parallel. To have the saddle guided by this side, I had to have something between the vertical side of the saddle and the bedway to have the saddle free of the original guiding area, this one. A 1mm feeler gauge between the vertical side of the saddle and the bedway did the trick. I cut the feeler gauge to the right length and then soldered some small pieces, one in each end, to prevent it from gliding out. This was in fact the very first repair I did to this lathe. I had to, or the lathe was useless. The next thing I made was a clutch for the lathe. It's a simple belt tensioner. I made some lengths to the original belt tensioner. It had a handle about this length. The reason for having the clutch handle here instead of up here is it's more convenient to have the hand here instead of over the chuck. I have also mounted a switch that turn on the power to the motor when the clutch is engaged. And it seems to work very fine. And when the clutch is disengaged, the spindle runs free. And then the tailstock. On these old lathes, the handwheel on the tailstock was situated about here, I think, as I recall, and the quill lead screw came out through the handle. It's a bit ignoring to have the lead screw sticking out of the handwheel. So I cut the handwheel in two parts. It's a casted handwheel, and I think the handwheel part is about to here, and the other part is to about here. And then I machined the parts to fit in a tube, and then secured the parts. I will screw off the handwheel and show that I have mounted a drawbar in the middle. It has two purposes. One is to draw out the tools from the quill, and the other thing is to support the unit. Index rings. This is the index ring that came with the lathe. It's graduated from 0 to 100. The lead screws on this lathe is metric. The cross-slide lead screw has a pitch of 4 mm. And I made a new one for this, adjustable, so it's rather clear to see what you're doing. I also made one for the top slide. By the way, this was not the original handwheel. It is, as I recall, from a toy sewing machine. The original was just like this. The last index ring I made was this for the carriage handwheel, but more about this in a minute. I never use the lead screw and the gear trains on this lathe to cut threads. I only use dies and taps for that. So therefore I made an adjustable power feed using a small car wiper motor for the purpose. This knob adjusts the power feed speed. It's a rather heavy potentiometer, and this is the forward and the reverse. The power for the wiper motor is a simple 12 volts battery charger. The power feed wiper motor has a switch as well as the headstock spindle motor has. So it's only possible to run the power feed when the spindle is running. And this was meant for safety reasons. So as you can see, if I didn't had the switch for the power feed related to the switch for the headstock spindle motor, and I forgot to unlock the lead screw from the carriage would continue to travel into the workpiece or the chuck and might cause damage. When I got the lathe, it had a AC single phase motor and a power switch, forward, stop and reverse. And it worked okay. But one of the best upgrades for this lathe was when I got my VIF and a 3-phase AC motor. The lathe runs much more quiet than with the single-phase AC motor, and it's really good with the variable speed control. And another thing is that it has a very great torque even at very low speeds. The next upgrade for the lathe was when I made digital readout for the tailstock, the crossslide and the carriage. Digital readout for the tailstock. I have used a digital caliper and cut it to the right length and shape, and the bracket for the caliper is a bit tricky to make because of the tailstock's rounded edges. The digital readout for the crossslide, again using a digital caliper cut to the right length and shape, and mounted on the saddle at this point and on the crossslide at this point. And it seemed to work very fine. And then last, the digital readout for the carriage, again using a digital caliper. It's mounted it in this end and at this end with a snap lock. The snap lock is meant to release the caliper when it is at its full length. These nice side feed oilers came with the lathe, meant to lubricate the main bearings. I have never used them. I have a plug in the hole for the side feed oilers and found that a drop or two to 3 times a day is sufficient. One of my latest upgrades for the lathe was when I got the quick change tool post. I've had the 4-way tool post for many years and it has been very good, I think. But I could really recommend to get a quick change tool post. When you have a quick change tool post, you also need some tool holders, and it could be rather expensive to have the tool holders for all your different tools. For machining, I mostly use tool bits grinded to the right shape, because you can grind tool bits to be very sharp and grind tool bits to the exact shape you like. My tool holders and tools From the left we have some parting off tools, and then we have a left hand tool for steel, a form tool, a tool for brass, a tool with a chip breaker for steel, and then we have some homemade boring bars in different sizes. The homemade boring bar it's a simple setup. It consists of a square steel bar that is counter drilled, and I have cut it through only at this side to be able to clamp the cutting tool. The cutting tool is a concrete drill bit with a carbide bit braced to the end. I have grinded the carbide bit to the right shape and for the right cutting angles. I made this rather big boring bar for boring out the cylinder liners for my model engines. The boring bar consists of a square steel bar, and I have drilled a hole in about 45 degrees for the cutting tool. It's a drill bit, and then I have drilled and tapped a hole at this point for a set screw to hold the cutting tool. Just a little more talk about the index ring for the carriage handwheel. I found that a full turn of the handwheel would move the carriage very close to 22 millimeter. The index ring is graduated in a tenth of a millimeter, and as mentioned, it has a full turn of 22 millimeter. Let's check the index ring to see how precise it is. I have set the carriage index ring to 0, and I will 0 the carriage digital readout, and let's try to give the handwheel a full turn 22 millimeter to see how precise it is. Yes. And about there. Yes, it's rather precise. Most of the time I use this English-made Bernard 3-jaw chuck. It's a very good quality and it's very precise. I also have this 4-jaw self-centering chuck, mostly used to machine square parts. So now let's see the lathe in action. I have a 10 mm steel rod and a chuck. The spindle speed is set to 900 RPMs, and I will try to make a cut of 2 mm. Let's set it to 2 mm. There. And yes, I know the overhang is a bit too long. Anyway, we'll give it a try. And now a finish cut, let's say about 500 of a millimeter, and slow down for the power feed. And let's check the surface. That's all for now. Thank you for watching and take care. Bye bye.